Hey! Hey! I'm Mr. O, here with another moment at the Children's Museum of Houston.
Please, can we do the demo?
Not yet. Patience. My rather impatient assistant and I today are looking at the science of dry ice.
Dry ice is frozen carbon dioxide, which means it's really cold, about negative 109.3 degrees Fahrenheit, which is about 4.5 times colder than normal ice compared to room temperature.
Wait, if it's that cold, why do some people call it hot ice?
Well, that's because it's so cold, it instantly freezes the water in your cells, causing frostbite very, very quickly. When you get frostbite that fast, your nerves interpret it as a pain sensation that feels a lot like burning. So it feels like you're burning when in fact you're actually freezing. That's why we're wearing our safety glasses and gloves so that we don't get that sort of sensation.
Cool. So now that that's settled, can we please do the demo?
Not yet. First we gotta explain why it's called dry ice.
Oh, that's easy.
Normal ice, when heated, goes through two phase changes. First, it changes from a solid ice to a liquid water. That's called melting. Second, the liquid water changes to gaseous water vapor. That's called vaporization or boiling. But dry ice only goes through one phase change when heated. It goes straight from being a solid carbon dioxide to a gaseous carbon dioxide. That skipping of liquid phase and going straight from a solid to a gas is called sublimation.
There, we talked about how cold dry ice is and how it goes through sublimation straight from a solid to a gas. Now, can we please do the demo?
That sounds like a good idea.
Here's one of the most common uses for dry ice. We take a bowl, add some very hot water, but not boiling, and then put in a piece of dry ice.
Whoa, look at all the carbon dioxide.
Now, a lot of people think that white stuff is the carbon dioxide, but that's a misconception. While you do see bubbles of carbon dioxide coming off the dry ice, carbon dioxide is clear. You can't see it. That white stuff you see is frozen water vapor. The extreme cold of the carbon dioxide causes the water vapor to condense into tiny ice crystals that are suspended in the air. In other words, that white fog really is fog.
This is so cool. I just wish we had some way to control it like a fog machine.
I think I know what we're going to do today.
Let's get building.
Science is fun, but it can also be dangerous. So always have a responsible adult helping you. And with dry ice, extra precautions need to be taken.
First, let's talk storage. Dry ice can be purchased at many grocery stores, but only by adults. Make sure to keep your dry ice in a styrofoam cooler. It's a good insulator and the interior will stay very cold. Never put dry ice into a regular freezer. A freezer is way too warm for dry ice, so it will sublimate away very quickly. Next, before handling the dry ice, make sure you're wearing insulated gloves to protect your hands and safety glasses to protect your eyes from stray pieces. Third, dry ice typically comes in very large blocks, far larger than you really need to use all at once, so it's best to break it up. Make sure to place any dry ice onto a cutting board or a piece of wood to protect tables and countertops. Then, gently tap it with a hammer. You really don't need to hit it hard to knock off pieces. Also, don't break up the whole block. The bigger the piece, the longer it will take to sublimate while being stored. Okay, now that we have our pieces, we're ready to start building the fog machine.
We're gonna make a fog machine.
To get a list of materials and instructions for how to make your own fog machine at home, visit the Children's Museum of Houston Kid Makers Project at kidmakers.org and search for fog machine.
The first step is to wire up and power a small fan, like a computer fan. Strip the wires if needed, and because this is a 12-volt fan, connect the fan to a pair of 9-volt battery clips. Connect the batteries to the clips and test the fan, checking the direction of the airflow and marking it. This will be important later. After the test, remove the batteries and secure everything to the fan. Now we need to connect the fan to the lid of our container. Use some painter's tape to cover the entire lid of the container, and then trace the fan's inner radius onto the painter's tape. Now we're going to use a Dremel to cut this, but you could also use a sharp knife. Either way, be very careful not to cut yourself. Once the hole is cut, use hot glue to secure the fan in place, making sure that blows down into the container, then set it aside. Again, lay down a little piece of painter's tape, then trace the circumference of the threaded end of a PVC pipe connector onto the side of the container and cut it out. Screw the connector into the hole, hot glue it into place, and then apply the PVC pipe into it. To work it, first, place a piece of dry ice into the container and then pour hot but not boiling water on top. Put the lid on, plug the batteries in so the fan is running, and watch as the fog comes rolling in, or rather in this case, blowing out. This has been another Oh Wow moment from the Children's Museum of Houston. We hope your mind can come out to play.